Hello, physics students. I am Mr. Williams, and this week we are going to be talking about volcanoes. All right. A lot of cool animated GIFs in this lecture. I hope you enjoy it. And look at this image here of this volcano. I believe this is a cauldron volcano, that hot melted rock. How much heat does it take to melt rock? Well, however much that is how much heat is here. Which leads me to the first definition that we'll be talking about, melting point. Melting point is the temperature that an object melts. Here we're talking about what temperature does the rock melt. Viscosity is a fluid's resistance to flow. And when we talk about volcanoes, we're talking about the viscosity of lava. How much does it flow? Does it flow poorly? Does it flow very well? And this is a good type of measurement to use when you are measuring the viscosity of oil for your car. Your car is going to need a specific type of oil with a specific type of viscosity, and it's something that's used in factories when measuring the viscosity of different materials. This image you can see all the way to the left, there is a low viscosity, and as you go to the right, it has a higher and higher viscosity. Cinder cone volcanoes are small, violent, erupting volcanoes formed by the accumulation of large pyroclastic materials around a vent. Okay, the pyroclastic material, pyroclasts are the solid materials that are exploded from a volcano. And then vents are just where the material gets out. A shield volcano is a broad, flat volcano formed by layers of free-flowing basaltic lava. Basaltic lava is just a type of lava, and it's basically formed from a rock called basalt. Composite volcanoes are large volcanoes formed by alternating lava flows and violently erupting pyroclastic materials. Very violent volcanoes, these composite volcanoes are. Okay, there's going to be two videos that I'm going to post online because it just doesn't work here. If I play the video, I can hear it, but you can't. So stay tuned. Now, the origin of magma. Magma is molten rock. It's melted rock, okay? And it has a lower density than when it is solid. So lower density materials float on high density materials. So we have this rising molten rock that can be forced towards the Earth's surface, right? It's getting less dense, so it wants to float on top of the solid that it came from as it is heated up. And you got the weight of the world literally pushing it down. And so if there's a crack between where it is at to the surface, it's going to get pushed up, and wada-ta, we have a volcano. So the pressure pushes the magma up. It is released at the surface in the form of lava. Volcanoes are most common at tectonic plate boundaries. Volcanoes can emit solids, liquids, and gases. Solid materials exposed by a volcano, excuse me, not exposed, expelled by a volcano is called a pyroclast. Okay, solid things that just come out of a volcano is called a pyroclast. Lava can be launched into the air. It can cool down and fall as ash. It can fall as rocks or something called a volcanic bomb. In the bottom right, you see this large boulder, which was once lava that was shot into the air. And before it hit the ground, it cooled enough to form a giant rock, which very hot, as you can see, still glowing red hot, and dangerous stuff. You don't want this falling on your house or a forest to cause a forest fire. Very powerful things. So gases released during volcanic eruptions are they're going to be superheated and they're going to have different compositions. So the superheated gas release, they're going to go very high into the atmosphere. and they're going to travel very far throughout the world. The most common gas that is released is superheated water vapor, so superheated steam. Carbon dioxide and sulfur compounds are also ejected into the atmosphere. In this animated GIF right here, you can see that the explosion sent a shockwave down the volcano, and it caused the humidity in the air to condense and form these clouds, right? Stuff that's coming down the mountain immediately is the condensation of air from the violent explosion. Magma from volcanoes or small cracks called fissures may remain liquid and flow as lava. So this fissure, this crack that's right there in the earth, can just flow and it remains liquid. Temperatures can affect the viscosity of lava. And remember that viscosity is the measure of the resistance of a fluid flow. So higher temperatures mean that things are going to flow well. They're going to have a lower viscosity. High temperature, low viscosity. Something has a low temperature, it's going to have a high viscosity. So it'll flow very poorly. Okay, low viscosity flows very well. High viscosity flows very poorly. When you have gravy for your mashed potatoes, it will flow very well when it's hot, but as it cools, it won't flow as well and it starts to solidify a little bit. So that's an example of how temperature can affect viscosity. Eruptions can occur as violent explosions. They can be free-flowing lava. It looks like we have some free-flowing lava in this animated GIF here. Or it can just be a quiet eruption. High viscosity, very thick magma builds high pressure and can lead to explosive eruptions. Makes sense. So if the fluid is very thick, more pressure can build underneath it because it's resisting moving out of the way, right? And by the time enough energy does it, it could be enough to cause a violent explosion. But when you have low viscosity magma, it's very runny and thin. The eruptions are usually very easy and they don't produce as violent as an eruption because that pressure is released because that fluid is always flowing. Most of the Earth's volcanoes are located in a place around the Pacific Ocean called the Ring of Fire. These volcanoes lie in areas where subduction zones are believed to be. Remember, tectonic plate movement. Subduction zone is an area where it is believed that one layer of the Earth is going under the other plate tectonic boundary. And as it goes underneath it, it's believed that that material melts. And as it melts, it creates another source of magma that can fuel volcanic eruptions around the Earth. Divergent plate boundaries, remember the plate boundaries that move apart from each other, they are also volcanically active, but they occur mostly underwater. Hotspots are volcanically active sites where large quantities of magma move to the surface. Okay, at Yellowstone National Park, there's a lot of lava underneath the park, and you can actually measure in areas how much the ground is going up and down. And in the image in the top right, you can see where the road is actually starting to melt, where it is getting so hot and it is being affected by these hot spots. Hot spots can form in the ocean. The Hawaiian Islands are an example of that. Yellowstone National Park has hot spots where we have these geysers, the superheated water underneath the ocean, underneath the surface of the ground, and where they heat up and enough pressure builds up where they just shoot up the steam and hot water into the air. Really cool stuff. So we're going to talk about three types of volcanoes. There are more types than that, but we're going to focus on three. You do need to know that volcanoes are classified according to their size, the shape, and materials that compose them. The temperature, composition, and the gas content of the magma also affect the type of volcano that we have. Important. Cinder cone volcanoes tend to be small, with heights in the hundreds of meters. Mount Kilimanjaro is an example of a cinder cone volcano. and you have an image of that in the background. Shield volcanoes from high temperature fluid. It should be form from high temperature fluid lava. Lava from shield volcanoes can move kilometers of the Earth's surface before stopping because such high temperature, it flows very well. It's very fluid, very runny. And so as it spills over to the top, it'll just form a thin layer and it's going to flow very far distances. And so that means these volcanoes are broad, flat structures made up of many layers of volcanoes. And Hawaii has many shield volcanoes. Composite volcanoes are composed of alternating layers and are very, very large. They're often thousands of meters high and tens of kilometers across. So Mount Rainier is an example of a composite volcano, very large. In this image of Mount Rainier, you can see that there is a village in the bottom, and many miles away, you can see Mount Rainier, a very large volcano. So that is the end of today's lecture. This is the we have 2 weeks remaining to the end of the semester. Make sure your work is caught up. At the end of next week, the Google Classroom will disappear. It will no longer be here, and you will have a whole new class schedule. So whatever is not finalized by then, um, will will be finalized. So make sure that you stay caught up. Come to class. When you come to class, have your questions ready and be ready to participate. Guys, have a great week. Bye.